Great, we're almost there. We only have one more talk until before this last discussion. And our last speaker is Fermín Alcasena. He is a PhD student with the Department of Agricultural and Forest Engineering of Universitat de Lleida. And his group are experts on fire risk assessment, fire behavior modeling, and forest management. And recently, they've been disentangling the key causative factors that contribute to fire risk. So I'm sure this is going to be a very interesting talk.
Okay, thank you very much. So, my name is Fermín Alcasena. I'm forest engineer, and in this short talk, I will advance some interesting ideas for a cross-scale wildfire risk management for Mediterranean landscapes in order to better coexist with fire. So again, better coexist. We try to live with fire in our landscapes. And to start with, I just wanted to point to the problem, which is the large fire. Our problem is the large fire, because we know that the fires can play a positive role in natural ecosystems. These fires are mostly caused by humans, escape from initial attack, overwhelming suppression capabilities, spread for very long distances, account for the bulk of the burnt area, and cause very substantial losses. If you want to compare the US with Europe, I was looking at your numbers, and I think we had almost the same number of fires, about 50,000 every year. When I talk to Europe, I'm referring to Portugal, Spain, Italy, Greece, and southern France. We've got almost the same number of fires, but in the US, they were having, I think, 3,300,000 hectares, and we've got about we don't reach to the 500,000 hectares. So we have proportionally more fires, but smaller, okay? And we can say that the aggressive full suppression policy is not working, it's failing to protect our values, and we need a long-term solution to coexist with fire. So from this, here we will try to advance some new ideas for a cross-scale wildfire risk management approach. In our cross-scale approach, we identified 5 levels. The first one is related with citizens, is related with humans, because humans cause more fire ignitions, and this is essential to understand how these fires locate in the landscape, which are the causes of these fires, and following this first level, we have a specific research line which is focused in fire occurrence modeling. Then we have the housing units, we have the families, the structures, where the home ignition zone maintenance is essential. Here we've got the social vulnerability concept, and related to this block, we have been working to assess the economic losses at individual structure level. On the next level, we've got the community. We've got some houses, okay? And here, we've got a fire shed. We've got an area where ignited fires can reach communities. And here, we've got a collaborative planning approach. To face and analyze this, we are focusing in large fire spread modeling to understand which are the fires that reach our communities. On the next level, we've got the municipality, where we can find the communities, we've got forests, we've got grasslands, we've got fruit trees, we've got a mosaic of properties, and here we've got a risk governance problem. We need to deal with the trade-offs, to prioritize, to protect forests, to prioritize, to protect communities, and how to deal with these different priorities we have in the landscape. And finally, here we've got a landscape treatment design approach where we compare, analyze, and study which are the different patterns according to the objectives of the treatments. Buoy protection, protecting forest, reducing transmission, and others. And finally, we've got the region, which is the big picture where we've got the different municipalities, and here we are trying to develop a wildfire management cohesive strategy, and this is more about policy making. Here we've got different priorities, and we are exploring how different management objectives can be distributed on the landscape depending on particular constraints and opportunities. So the first block, fire occurrence modeling, we can predict the ignition locations with a very high accuracy. This is just to show you one example. This is a map for a 50,000 hectare frame where results are shown at 50-meter resolution, where we can see that the human ignitions show a very clear pattern. We've got higher values close to the urban areas and close to the roads, and remote areas with very bad access have lower values, okay? We are doing this analysis now at much higher scales without losing the resolution of the calculations. To do that, we need very accurate data. Without an accurate database, it's impossible to generate these models. So here again, I would like to emphasize how important it is to do a good report for the fires. And this information is used to locate the fire ignition for our modeling approach. We need to know where are the locations which are the locations where the fires will likely ignite. Okay? It's not homogeneous. Then we have been assessing the economic losses to property. We have been doing studies at individual structure level. This was published in previous studies, where we first model wildfire spread and behavior, and then in a second component, we estimate the susceptibility of the fire. So first, we have the probability, and then consequences, according to the FINE 2005 framework, widely implemented in the US, accepted by many researchers, Dave Culkin, Alan Agar, Matthew Thompson, and others. And with this, we can know for every single structure we have on the landscape, which is the expected economic loss. No index here. This is a quantitative value. So then we've got the fire modeling need to estimate the extent of the area where the management can have effects on our communities. And here we can clearly see that, this is the key message, that the administrative boundaries do not fit with fire sets. There's a mismatch. So the management in your neighbors might affect you, and this has a very strong implications. This is highly dependent on the fire weather scenario. So for conditions where we have very complex situations, this can get more complicated, but overall we've got some dominant conditions. We need very accurate structural location maps to do this. Next block, treatment design. We have been doing multi-objective analysis where we have a big landscape, we have different objectives, and we can explore the trade-offs. So is there any opportunity between treating for risk reduction in communities and treating for reducing losses in forest lands? This is the trade-off analysis that some of you have been talking about. And then finally, we have the fire policy big picture, where we have a big landscape, and according to main core goals, we have different priorities. The way we are managing fire is not homogeneous, cannot be homogeneous. So we've got first core goal, generate fire resilient landscapes, okay? And here the management is field treatment, so we identified priority areas for this core goal. We've got the cultural fire regime, so we can identify the areas where humans play a key role in reducing loads, and other areas where ignitions can cause a high damage. So in some areas we prevent ignitions, and in other areas we somehow facilitate this fire use. The third core goal is to to support a safe and efficient response. In other words, we need to focus, we need to prioritize suppression on the areas where this is effective, safe, and efficient, okay? It's not a kind of random response everywhere. And finally, we've got fire-adapted communities. We have some areas with very high structure density and high exposure values. So if we want to prioritize this goal, we should focus to those municipalities where we have high density, but not only this, high exposure values, okay? And this is it. So thanks for your attention, and these are the 4 last papers we have. If you want more details, you can go to the references and try, and I'm open here to any question you have as well. So thank you.